first thing we're going to do is we're going to factor it if it's factorable. So x plus 4 minus 4 over 4x. Alright, I'm going to check if there's a whole. There's nothing that cancels out here, so there's no whole. Second, we're going to find the x-intercept. How you find that, you set the numerator set to 0, so we have 4, 0, and then we have negative 4, 0. Okay, next is a y-intercept, and we do that by putting in zeros for all the x's. So then we have 4 times negative 4 over 4 times 0. Because there's a 0 at the bottom, there is none. So I'm going to put no y-intercept. Alright, next we have the vertical asymptote. We do that by setting 4x equal to 0, and we divide by 4 on either side, so that gets us x equals 0. So x equals 0 for the vertical asymptote. Next we have the horizontal asymptote. Now, because the degree is higher on the top, the numerator, that means that we're going to have to do long division, so it's going to result in a slant asymptote. So we're going to do x cubed minus 16 for x. So you want to do this out, right? Set that equal to that. So x squared 0. Can't do that, but we're only going to take this number here. So y equals 1/4 x, and I'm just going to put plus 0 for my own vote. Now we're going to graph the equation. So I already put up some points here. The way I found these, I plugged in this for the x value in our original problem, x minus 16 over 4x. Okay, so now we start. The way we start, we first draw on the asymptotes. Like I said before, the vertical asymptote is 0, so I'm going to put a dotted line here. And then the horizontal asymptote, which is the slant asymptote, is 1/4 x. So I'm going to draw 1, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4. So these are both of our asymptotes. So now I'm going to put in the x-intercept, which is here and here, right? So we know the lines are going to have to be on these sides because you can't cross the asymptotes. So I'm going to take the points that I already calculated back and plot them here. So at 1, I have negative 15/4, which is a little bit over 1. So right about, I'm going to put 3.75 right about here. And then we have a 2, negative 1/4. So 2 is right about here. And then I did 5. Right, so I got negative like 20th, which is like that. Kind of gonna go somewhere like that, but it's never gonna intersect these asymptotes. Repeat with this set of points that we already plugged in. There, and it's here, there. So that's like smoother. All right. Final graph. So now we have to find the domain and range. So this would be negative infinity, right? It goes out to 0, but then it's going to go back up to 0, infinity. Then for our range, it's going to be, it goes on for infinity here, and it's going to go on for infinity here. And so that's going to be negative infinity to infinity.
Okay, so this is our first equation. So first what we're going to do is we are going to factor it out. So the top is going to stay the same, the numerator, but the denominator, we can factor it into x plus 4, x minus 4. Okay, and stop it there. Okay, so next thing we're going to do is wholes. This, in this case, does not have one, but if there were to, it would be like, say there's an x plus 4 also up here, we would cross it out and it would be out of the equation. Okay, so for the y-intercept, we're going to be plugging 0 in for our x that we have. So it's 16 over 0 squared minus 16. And that's going to go out to 16 over negative 16, which is negative 1. And we're going to write it as a coordinate, so it's going to be 0, negative 1. For the vertical asymptote, all we have to do, since we already factored it, is we're going to set the x plus 4 equal to 0 and the x minus 4 equal to 0. So we're going to get x equals negative 4, and then x equals 4. And then these are going to be our two vertical asymptotes. So next we have the horizontal asymptote. And that is when you have degrees. So when the bottom degree is greater than the top degree, the y is actually 0. So first thing I'm going to show on the graph is the asymptote. So for our horizontal one, that's just going to be the 0. And then for our vertical, it's a negative 4 and 4. So 1, 2, 3, 4. And then negative 4. Okay. And then these are going to be, there's actually going to be 3 parts to this. So we're going to start off with 0, 1, and negative 1. So to get our points, all we did was we took points off the graph, so 0, 1, and negative 1 for x, and we plugged into the equation and got our y value out of it. So for 0, it's negative 1. For 1, it's negative 1.1. And then for negative 1, it's negative 1.1. Goes like this. And then over here we have negative 5, negative 6, and negative 7. So negative 5 is 1.7. Negative 6 is 0.8. And then negative 7 is 1/2. And then we're going to come over here, and keep in mind we can't have our lines going on our sentence, so they're all inside or outside of it. So we have 5, 6, and 7, so 5 is 1.7, 6 is 0.8, and 7 is 1/2. It's kind of mirroring our other side with our negative values. And this is our graph. Okay, so our domain is going to be negative infinity to negative 5, which is over here, and then it's going to start again over at negative 3 to positive 3, and then from 5 to infinity. And then our range is going to come from negative infinity up to negative 1, and then from 0 to infinity.
So this is our equation. First we're going to check if we can factor, but we can't factor here. And then we're going to check if we can find a hole. Nothing cancels out, so there's no hole. Next we're going to find the x-intercept. To find the x-intercept, we have to set the numerator equal to 0. So 3x minus 2, we're going to bring over like that, and then that's going to be x equals 2/3. We're going to write it as a coordinate, so it's going to be 2/3, 0. Next, we need to find the y-intercept. To find that, we set all x's in the equation equal to 0. So this gets us 2. So we're also going to write this as a coordinate. We're going to put 0 in the x spot, and then 2. Next, we're going to find our vertical asymptote. To find that, we are going to set our denominator equal to 0. So we're going to have 2x equals 1. So then x equals 1/2. So x equals 1/2 is our vertical asymptote. Next, we're going to find our horizontal asymptote. So we're going to look at and see the degrees of our original equation. Because they are the same, it's going to be a ratio. So we're going to take the coefficients of these two. So y equals 3/2. All right, so now we're going to graph. We are going to take our vertical asymptote and draw that in first. Right, so we have it at 1/2. Next, we're going to take our horizontal asymptote, 3/2. We're going to put that right about here. All right, that looks about good. All right, now we're going to plot whatever zeros we have. So 1 here, because it's at 2, and then 2/3, which is right about here, kind of. All right, so over here is equations we already did that we plugged in, x equals back in. So when this equals 2, it's right about here and then here. So we're going to draw that in. It's never going to touch the asymptote, right? And then that's going to go somewhere like that. And next we're going to graph the other part of our equation thing. So it's going to be at -1 right about there, kind of. And then at 1/2 it was somewhere like there. Hold on. So then that's going to go something like that. Alright. We're going to look back at our graph. So it looks like it's going from negative infinity to 1/2 to 1/2, right? Because it can't ever touch the asymptote. There. Alright. Now for the range, it's going to be from negative infinity to 3/2 up to 3/2 to infinity.